going to be a three-staged process in your proof by induction, in which the first stage would be when you'll be proving your certain equation or your statement that it is true for n is equals to 1, which means that you'll be substituting n is equals to 1 in your equation and proving that it is right or it stands true for your n is equals to 1. In the second stage, or in the second step, you're going to be assuming that the statement is true for n is equals to k. In this step, you're not going to be saying that, you're not going to be proving that it's equal to n, it's true for n is equals to k, but you're just going to assume that it will stand true for n is equals to k. And in the third step, what you're going to do is you're going to prove that the statement is true for n is equals to k plus 1, which means that you're going to be substituting your n with k plus 1, and you're going to prove that it stands true for n is equals to k plus 1. Now, if your statement, if all of these apply to your statement, which means that all of them are true, that means that your statement is true for all values of n that are equal to or greater than 1. So any value that you'll be going to putting into your equation or substituting into your equation that is equal to 1 or greater than 1, which means it's going to be a positive value, it's always going to stand true for your certain equation. Now let's come towards an example to make things more clear. For example, the question would say that prove by induction that your summation formula of n r is equals to 1, r is equals to n plus 1 divided by 2. You have to now prove by induction that this stands true. So the first step that we learned was to substitute our n is equals to 1. Now, how we're going to substitute is that we're first supposed to substitute it into the right-hand side of the equation. So in the right-hand side of the equation, you have n plus 1 over 2. So you're going to substitute your n with 1. So you get 1, 1 plus 1 giving you 2 over 2, and your 2 gets cancelled and you get a 1. So you got a 1 when you substituted n is equals to 1. Now, when you do the same on your left-hand side, you get substituting n with 1, r is equals to 1, and your r, so your r from 1 to 1 will become 1. We've already done this formula. When we substitute it into the formula related to this in your formula booklet, you'll get your answer to be as 1. So your left hand side is equals to your right hand side. So this is all that you're going to be applying in your first step of your the the first stage of your answer. Now in the second stage, they said that you're going to assume that your n is equals to k. Now this is not a proving part of your question. You're just going to assume that your statement stands true when you're putting you're substituting your n with k. So now in this one, you're going to be substituting your k into the entire equation, because it's not going to prove anything, since we're just assuming we're going to substitute it into the left hand side and into the right hand side at the same time. So when we substitute our equation with k instead of n, what we come up with is, you had an n over here, so it's replaced with k. You have r is equals to 1. You have r is equals to k plus 1 over 2. So we're just assuming that this equation stands true. We don't have a proof right now, but we're just going to assume this in the step 2 of your process. Now moving towards your step 3. Your step 3 said that you have to prove that the statement is true for n is equals to k plus 1. So now you're going to be substituting your equation with the k plus 1. So in the left hand side, you get k plus 1, you get r is equals to 1, you get r. So when you're going to be expanding it, since we know that in the top one, we've always learned how to deal with a formula that just has one digit or one alphabet or just one value on the top. So to remove this extra value of plus 1 that is going with our k, what we're supposed to do is we're going to take it down. So taking it down means that we're going to be making your k plus 1 k again. Your r is equals to 1 comes down, comes as it is. You have r, and then you're adding an extra factor in your formula, that is going to be your k plus 1, which means that the k plus 1 that was on the top, we've just removed that, we've added k over here, and the k plus 1 came down in your formula and got added. So now this is what your formula becomes. Now this was the left hand side of the equation. Now towards the right hand side of your equation. What happens on the right hand side of the equation? Your equation now becomes uh, k plus 1 over 2 plus k plus 1. Now you've got this equation and you're going to be solving it in such a way that you get your first equation again. Wait, let me just write it on the next page. So we got on the right hand side k plus 1 over 2 plus k plus 1. And we're going to just simplify it in a way that you go back to your question, which said that your answer must be equal to, your right hand side must be equal to n plus 1 over 2. Now, simplifying this right hand side that we have in our question in the third stage, you get, for example, what can we do with this? We can take your k plus 1 common from both. So we have k plus 1 common, and then you have k over 2 and plus 1 left. So now if you take your 1 by 2 common, you can to take it into this form, which means that there is a 1 by 2 factor that is multiplying with this. So we take 1 by 2 common and we have k plus 1 and we have k plus 2 over here, because 2 into 1 by 2 would give us 1 over here, which is on in the last step. So you get 1 by 2 k plus 1 k plus 2, and when we are going to simplify it further, you will be getting k plus 1 k, sorry, you're going to be adding your other brackets here. You're going to be getting k plus 1 plus 1 over 2. Now this is the same as this. How? What we did is we substituted our n with k plus 1. Now, whenever you're going to put your n is equals to k plus 1 in this specific question, or in this specific part of the equation, your n is replaced by k plus 1 over here. Your this n is replaced with k plus 1 over here. Your plus 1 comes right over here, and your 2 is also being divided, which means that we got back to the form that was asked in the question. So this is going to be a three-staged process you're proving by induction, in which first you're going to substitute your n is equals to 1. Then you're going to substitute your n is equals to 1 in the right hand side and the left hand side of the equation, and you're going to prove that it stands true for the statement. In the second step, you're only going to be assuming that it stands true for n is equals to k. And in your third step, that is the main and the most final, the last step, that is the most important one, in which you're going to be substituting your n with k plus 1, and you're going to be getting an equation in the same format or in the same pattern as the one that your question demands. All right, Meher, is that understandable?
Yes, yes.